All right, today I wanted to do a little recap on balancing chemical equations. I just uploaded a video explaining my step-by-step methodology of how I would balance chemical equations. Um, I'm sure you're familiar with the phrase I before E except after C, or neighbor, or in words like neighbor and way. And then you go and you maybe have a spelling test and you spell weird wrong, or your teacher marks you off because you did that wrong, and it's because the I is on the wrong spot. But the point is, there's always exceptions to little strategies or rules or gimmicks to get you to remember how to do some simple thing. So anyways, instead of going through all those exceptions, I just wanted to make a video of me doing as many of these problems as I could to get you familiar with this. I believe that the best way to be good at balancing chemical equations is just to do as many of them as you can. Just get familiar with your own thought process of doing it. I'm gonna talk through my steps, or I'll just talk through it, and then if that's helpful, just listen to what I'm thinking while I solve these problems. Anyways, I'm gonna do as many as I can do in 5 minutes. The first two that I do, I'm gonna use the same methodology that I tried to explain last time. So without further ado, oh, and by the way, I just picked these all randomly. I did not prepare anything. I didn't try them at all. So you'll just see it for the first time here. So here we go. All right, we're gonna start this one using the method that I showed in my last video. So without any further ado, so we got on the reactant side, we got an iron. We got one iron, and we have two chlorine atoms. On the product side, we have one iron. We have three chlorines. Right away we see that the irons are already balanced, but the chlorines are not. And the way I would do that really fast is just multiply this by 2, multiply this by 3. Now the chlorines have 6 elements on each side, but the iron is now off balance 2 to 1, so we multiply the first one by 2. Alright, so here for our next example, just going to go right into it. We've got potassium, we've got nitrogen, we got oxygen, hydrogen, and carbon. We have one potassium, we have one nitrogen, we have 3 oxygens in each molecule, we have 2 hydrogens, and we have 1 carbon. So on the product side, again, we have potassium, nitrogen, oxygen, hydrogen, and carbon. We have 2 potassium, 1 nitrogen, 3 of each oxygen, or 3 oxygens in each molecule, 1 hydrogen, and 1 carbon. Just balance the potassiums right away. That's K, but this affects the nitrogen and oxygen. So that gives times 2 here and times 2 oxygen in this molecule. Let's go on to nitrogen. Quick way, just multiply that by 2. Now our hydrogen is doubled and our oxygen for that molecule is doubled. Let's see if there's, nitrogen, nitrogen? Oh, it's already, yeah, it's balanced. So there we go. All right, now I'm just going to show you how I would do these problems without writing anything down, or I'm just going to talk through it and, fill in the blanks basically. So here I go. All right, so it looks like our oxygens are actually balanced right here. Hydrogens aren't, so I'm going to balance those really quick. 3, 2, that messes up the oxygen. It also messes up the nitrogen, so we'll try to balance the nitrogen, see what it does to oxygen. We have 2 oxygen here, 3 oxygens here, so that's 5. So that's 5 halves here. So if we multiply this whole thing by 2, we're going to have 4 NH3 plus 5 O2, 4 NO plus 6 H2O. Let me just really quick check to make sure I did that right. 4 N's, 12 H's, and 10 oxygen. Perfect. All right, just getting right into the next one. I see we got potassiums out of balance. I'm just going to balance that really quick, see what happens to the hydrogens. We got 6 hydrogens over here, so I'm going to put a hydrogen over here. Now we have, make sure the potassium is balanced. Okay, then we have 7 oxygen over here, and we have 7 oxygen over here. It looks like it's balanced. Let me just quickly double check. 3 oxygen, 3 hydrogens. We got 4. Wait, do we have 4? No, we have 6. Perfect. Check. All right, so our next problem looks a little crazy. It let's get into it. So carbon 5 even, 8, 9, 10, 12 here, so that's going to be interesting. Sodium's balanced, chlorine's balanced, oxygen's balanced. It's actually just the hydrogens that's out, 8, 9, 10, so I want 2 somewhere. How can I affect 2? Well, I can't. That's actually really weird. This is really strange. This is a good one. But now that affects the Cl right here, so if I put 2 here, we have 4 H's plus 8, 9, 10, 11, 12. Hey, that works. Good stuff. All right, here's another one. So right away, I see carbon's balanced already. Let's look at the nitrogens. Nitrogen, we have 1 here, we have 3 here. So I'm going to put a 3 out front, 6 more hydrogens, and we have 9 oxygen. So 6, 7. I want to put 2 here because that would balance the oxygen and see what that does to the hydrogen. 6 plus 4 is 10, 3. Okay, so I had to stop the video because I saw that it did something wrong really fast. This should be 3. There it's balanced. 6 plus 6, 12. 12 hydrogens on the side, C7. Nitrogen is balanced and oxygen is balanced. Alright, so this is going to be our last one. Let's just get into it. So right away I see we have some boron. So I'm just going to put a 2 here to balance that boron. Let's see, that's F is 6. So there's only an F here, so I got to put a 6 here. Lithium, so that means I'm going to have to put a 3 here. I think it should be balanced at this point. Let me just make sure the sulfurs are balanced. 3 sulfurs, perfect. Looks good. 9 oxygen. All right, so that's going to end this video. Hope this was helpful. If not, let me know in the comments below. Thanks.